Hello everyone, my name is Chris Edwards and today we are going to write a SQL query. Our problem today is typical of many real-world SQL problems you may encounter in that no one piece of it is particularly difficult, but parsing out what all the pieces are and arranging them into a solution requires a bit of thought. The operator of a humble pastry stall at a weekly farmer's market wants to get a financial picture of their fledgling business. Specifically, they want to know the average daily revenue per product in the month of February to find out which pastries are the best for business. The young pastry chef has created two tables in a database with the following structures. The product table, seen here, contains one record per product sold at the shop, along with the product's current sale price in US dollars. The sales table contains one record per product per transaction. If multiple different types of products are purchased in a single transaction, each product type will get its own row in this table associated with the transaction's timestamp. And if a customer purchases multiple of the same product at one time, for example, 2 muffins or something like that, they will be indicated by the number in the product quantity column. So taking a specific example here, this row indicates that someone purchased 5 of product number 3. Product number 3 is cookies. So someone bought 5 cookies at 9:01 on February 1st. We need to write a SQL query that returns the average daily revenue per product name in the pastry chef's database. And a couple additional notes here. The pastry stall is only open on Saturdays, so you don't need to somehow account for non-Saturdays in your analysis. You just need to find the average across the dates that actually appear in the data you're given. Also, you don't need to round or otherwise format the averages you compute. For example, 3.1456 instead of nicely formatted $3.15 is totally fine. And just for reference, these are the actual expected results you should get once you've completed your query. And that's it for today's setup. If you want to have a crack at solving this problem yourself, there are links in the video description to this full problem statement and instructions on how to replicate this coding environment on your local machine. Feel free to pause the video now and come back later for a solution walkthrough coming right up. All right, welcome back everyone. We will now take a look at a possible solution to this problem. As I mentioned before, I don't think this problem is particularly difficult, but it has several components to it that you need to think through in order to figure out what actually needs to be done. So I'm going to try to walk through how to break down this problem. We are being asked to calculate the average daily revenue per product name. So let's break that down a little bit. First off, we need to calculate an average of some kind. So let's go ahead and pencil that in kind of a stub query here. And if we need to calculate an average, that means we need to aggregate something. More specifically, we need to get an average of something per product name. So when we aggregate, we will want to group by product name. All right. So we have this kind of skeleton starting to form here. What next? Next, we need to figure out what we need to plug in right here. What are we calculating the average of? What metric do we need to plug into the average function? Well, looking back at the problem statement, we need daily revenue. Now, unfortunately for us, if we look back at the tables we're given, we don't have a column for daily revenue in our source tables, so we will need to construct one ourselves. So let's leave this little skeleton of the problem for a bit and just zoom in on the issue of daily revenue. Let's figure out how to get that first. The concept of daily revenue has two components, the daily part and the revenue part. Let's zoom in a little further and address each of these in turn, and let's start with revenue. So our sales table here does not have a revenue column, but it does have a quantity column. And if we join up to the product table, we can get price data. And what is revenue but quantity times price? So let's use all of that to create a revenue column for our transaction data, like so. And let's bring in product name from the product table while we're at it, since we know we're going to need that later. All right, so we've solved the revenue half of the daily revenue problem. Now let's tackle the daily part. We currently have this transaction timestamp column, which is close to what we need, but not quite there. This column has both date and time information, but we want a coarser-grained column that just has date. So we need to convert this transaction timestamp column into a transaction date column. There are multiple ways you can do this, and the syntax for many of these ways will be highly database system dependent. You could extract the date from the timestamp, you could cast the column to a date type. There may be some other ways, but for simplicity's sake, I'm just going to cast the data type to date using this double colon syntax you see right here. This is supported in a variety of database systems. And as you can see here, we have now successfully converted our timestamps to plain dates. Okay, now we have the necessary columns at our disposal to calculate daily revenue per product name. All we need to do is aggregate by date and product name and compute the total, also known as the sum, of the revenue. And for that, we can employ a simple group by statement, and voila. As you can see, we have now constructed a column for daily revenue. And just to be safe, we can do a quick spot check to make sure we are calculating this correctly. Let's take muffins on February 1st, for example. This table is saying we made $9 from muffins. If we look back at the test data for our sales table, muffin is product ID number 1. On February 1st, we had 2 transactions for muffins. We sold 2 muffins, then 4. That's a total of 6 muffins sold. The price of muffins is $1.50 each. 6 times 1.5 is indeed $9, which is what we see in the aggregate here. Okay, so jumping back up a level, remember why we were doing all this in the first place. We needed to calculate the average daily revenue per product name. And that's what this little skeleton up here was for. Back then, we didn't have a column for daily revenue to plug into this average function, but now we do. So we essentially just need to restructure this a bit to be able to plug in this value into our average function. And to do that, just have a restructured query at the ready here. To do that, we need to wrap our daily revenue calculation inside a common table expression, or CTE. And then we can just select from that CTE and reference our daily revenue column right here. Put it right in the average function. And run that, and there we go. The average daily revenue per product name, exactly matching our expected results over here. Clearly, muffins are the big winner. Now, before I leave you for the day, I want to acknowledge that this is not the only query that solves this problem. In fact, depending on the circumstances, in a real-world situation, I might want to do a bit of additional work on this query in order to improve performance. This is another query that returns exactly the same output as the query that we had arrived at earlier. but it does so in a slightly different way, using a slightly different order of operations. And there may be circumstances where you would prefer this query over the other one. In our toy example here, the database only had 3 products and 20 transactions. But what if the pastry chef makes it big, goes multinational, and now we're dealing with millions of products and billions of transactions? If you are an analyst trying to perform this analysis on that dataset, you might find that just attempting to join the billions of transactions to the millions of products is a very expensive operation, even if the right indexes are in place. However, what if you switch up the order of operations? What if you compute the average daily quantity sold per product ID first, and only then join up to the product table to get product name and price and everything else you need to complete the calculation? Now, instead of joining the product table to several billion transaction grain records, you're joining it to a pre-aggregated product grain dataset that is potentially several orders of magnitude smaller. The cost of the aggregation is roughly the same between the two strategies, but the cost of the join might be substantially improved by the second strategy. Or not. That's honestly the kind of thing you have to performance test for your specific circumstances and your specific data. But it is important to always keep these kinds of optimization strategies in mind. If you find yourself with a slow query, you should ask yourself if you can reduce the size of the data sooner in your pipeline to make later steps more efficient. All right, well, that's it for this video. Thank you all for watching. If you have any further questions about this problem, or if you think of a different approach to the solution that I may not have considered, please let me know in the comments. And be sure to subscribe for more SQL query writing content in the future. Until next time, happy querying.